In this example, we'll demonstrate how to apply Kirchhoff's voltage law, KVL, to meshes and loops. So we'll start off, we're trying to find unknown voltages in the circuit, so we'll start off by trying to find V2 and V3 because those are contained within meshes. So let's label those meshes. So again, it doesn't matter which way we label them. So I'm going to label this one clockwise, and I'm going to label this one counterclockwise. It doesn't matter which direction as long as you follow what your direction arrow. Alright, so let's do a KVL. Let's call this 1. So we'll say we're going to go around 1 in this direction. Notice that they match. So we're just going to pick a point to start at, and we're going to walk our way around. So we'll start here. Alright, so this is the sum of voltage equals 0, if you don't remember what KVL means. So we go here, and we get minus 10 plus, and we keep going. So now we get to V2, plus V2, and then plus 8 equal to 0. So let's walk through that again. So for the minus 10, I'm picking up the negative sign that we enter. If, the write up is going to pick up the leaving sign. It doesn't matter which way you do it as long as you're consistent. So I'm always picking up the sign as I enter. So I'm going around this way, going around this way, going around this way. And I'm picking up the sign as I enter it. If you want to pick up the sign as you leave it, as long as you are consistent, it'll be fine. You'll get the same exact answer. If you don't believe me, go ahead and try it. You'll get the same answer. Alright, so you solve this for V2, and you will get 2 volts. So same thing, KVL, and we'll call this 2. So we'll go around 2 in this direction this time. So then this is sum of voltage around a loop equal to 0. I'll just start here. I'm going to go this way this time. I'm going to follow my loop direction. So we're going to end up with minus 9 plus 8. Again, I'm picking up the thing as I enter it. But if you want to pick up as you leave, go for it. And then minus V3, all equal to 0. You solve this for V3, and you will get negative 1 volt. Alright, so knowing V3, we could do another loop around a mesh in here. We could have V1, 10, and V3. But you can find V1 without V2 or V3 by just doing a loop. So I'll highlight that so you see what we're going to do. So we're going to go up here. We're going to go over. We're going to come down. So we have a choice. We can go through an unknown V2 or a known 10 volts. So we come over here through 10 volts. We have a choice. We can go through an unknown V3 or a known 8 volts. We'll go through the 8 volts. We want to keep coming down to here. So that is the loop that we can go through where we will pick up no unknowns. We won't pick up V2 or V3. So if I wanted to find just V1 without finding V2 or V3, that's how we would do it. So KVL, I'm going to go around this way. And really you would call this like 1, 2, and 3. So this is sum of voltage around a loop equal to 0. Alright, so we have minus V1. I'm going to start down here. So minus V1 plus 10. Again, I'm just picking up the sign as I enter it. Minus 8. And then plus 9, all equal to 0. And when you solve this for V1, you will get 11 volts. So again, this is just algebra. Now, just as kind of an aside, if this was, say, negative 10, then what I would do is I go minus V1, and I would go plus, and then I would write negative 10 here. So I would go plus, and then I would have plus parentheses negative 10, and I would keep going just so that you're still picking up the plus sign as you enter, but you're putting in the total voltage. So if it was negative 10, you put in negative 10 there.